Very good evening. We will continue our discussion on climate change, and we will be proceeding with global warming, global warming, and particularly we will be talking about greenhouse gases. Particularly, we will be talking about greenhouse gases. Greenhouse gases. Fine. So we started with climate change, right? So we discussed all natural factors. In anthropogenic factors, the first thing we are starting with, that is global warming, and we will mainly be dealing with greenhouse gases. So first we have to understand why it is called as greenhouse gases. So what happened, what used to happen in colder region earlier in colder regions, but now it is mainly in everywhere, mainly practiced everywhere, because we want to have a control over the kind of temperature we need in cropping area, right? So for example, a plant is there or crops are there, right? And this is the colder region, so what we have to do is we need to have a warmer air or little warm temperature for plants and crops, right? So we used to have a kind of glass ceiling or glass coverage, so that this glass is transparent for incoming solar radiation, right? Incoming solar radiation. So this heat is coming inside, right? This heat is coming inside this glass house, or making this temperature warm, keeping this air warm inside this house, and it is better for this plant and crops. But what used to happen is you can also consider an example. If you have parked your car, outside a road, right, and where sunlight is present, so this sunlight easily enters into your car through windows, right? Because windows are transparent to incoming solar radiation, solar heat. So this heat comes inside your car, but since window is closed or windows are closed, then this heat is not able to escape from this area. This heat is not able to escape from this area, and you will observe that this temperature is a little warmer from outside. As compared to outside, the temperature is warmer inside the car. But what you do, if you can have a little open window, then this warm air will escape from that particular opening. So if your window is open little, then this warm air will escape from this little opening, right? So what happens is, similar thing we used to see on these greenhouses also, that this we used to have a kind of window in this greenhouses, and when we feel that temperature is warmer, and we don't need these warm temperature or this warm air, so we need to open this window, and when you open this window, this warm air will escape from it, right? So from this, the greenhouse gas name concept is there. So what we are having now, this global warming impact, if we see, this is sun, right? This is sun, and this is our surface of earth. This is our surface of earth. This is a little, we need to have a little smaller one. So this is sun, and this is the surface of earth. This is the surface of earth. Now this is incoming solar radiation, So some solar radiations will be reflected back by the constituents of atmosphere only. So these are reflected back, and this is also when it falls on the surface of earth, when the sunlight falls on the surface of earth. For example, snow is there, or the substance are there which have high albedo. Albedo means reflective coefficient. So when this falls on this particular area, it gets reflected back. So these are reflecting back into the atmosphere, right? And some incoming solar radiations are trapped by atmosphere, trapped by constituents of atmosphere. For example, clouds are there, different aerosols are there. So these particular constituents of atmosphere, so these incoming solar radiations are trapped by constituents of atmosphere. Now see, some are coming incoming solar radiation, and these incoming solar radiation are being absorbed by the surface of earth. So when we see the percentage, what percentage is being absorbed and what percentage being reflected, so roughly it is around 30%. Roughly it is around 30%. You will see if we can call the albedo or reflection coefficient of earth. So albedo of earth is around 30 percentage, not 30, because albedo value, since it is a coefficient, its value ranges between 0 to 1, and 0.3 is roughly 0.3 is considered as albedo of earth. But see, in NCERT you will see this value as 0.35, so need not to commit mistake in the examination if it is given 0.35, so roughly you can remember as 0.3 to 0.35, right? So this is the albedo of earth. This is the albedo of earth. Planet Venus has very high albedo, that is somewhere around 0.75 to 0.85. Highest albedo among planets. Venus 0.75 to 0.85, right? So this is just information. So now these incoming solar radiations are being absorbed by Earth's surface, and Earth's surface means both land as well as water. Earth's surface means both land as well as water. Example, oceans are there on the surface of Earth. Just give me a second. For example, sea is present on the surface of Earth. So this incoming, so this is roughly around 30%, and this is roughly around 15%, and this is roughly around 50%. So whatever solar radiation is coming to the Earth, almost 50% of it gets absorbed by the surface of Earth. Now, when it is absorbed by the surface, what happens is, when sunlight is present, it's fine, it is getting the Earth surface is absorbing those particular incoming solar radiations. But when sunlight is absent, now what happens is this Earth surface starts radiating its heat. Now it starts radiating its heat. So this is radiating its heat, right? But see the difference. These incoming solar radiations are having shorter wavelength. So these are having shorter wavelength. So these greenhouse gases present in the atmosphere, if greenhouse gases are present in the atmosphere, if these greenhouse gases are present in the atmosphere, these greenhouse gases acting as a transparent medium for incoming solar radiation. So these greenhouse gases are acting as transparent medium. Incoming solar radiations can easily come to the surface of Earth. But when it is being radiated back to the Earth's surface, now these radiations are longer wave radiation. This heat radiation is longer wave radiation, and these radiation is getting absorbed by this greenhouse gases. We can just have a little big picture here. See, these are the greenhouse gases. These are the greenhouse gases present in the atmosphere, right? And this is the surface of Earth. This is the surface of Earth. Now these are the solar radiation. These are the solar radiation, that is heat going out, and it is being trapped by this greenhouse gases. Is being trapped by greenhouse gases, and some are able to escape also, right? Some are able to escape also. So when these outgoing heat radiation is absorbed by greenhouse gases present in the atmosphere, these greenhouse gases reflect them back in all direction, effectively in backward direction. So it radiates this greenhouse gases in this heat in all direction, but these backward radiation, this will again come to the surface of earth, this will again come to the surface of earth, right? And it will make the temperature warmer and warmer. It will make temperature warmer and warmer. So this is the reason of greenhouse gases, how these greenhouse gases are impacting global warming. These are increasing this particular temperature. This atmospheric temperature is being increased due to the greenhouse gases. Understood? Yes. Fine. So this is the idea of this particular greenhouse gases, right? Now we have also seen the albedo of different planets and all. So sorry, not different planets, but highest albedo is of planet Venus. But these greenhouse gases, are they really bad? These greenhouse gases, are these greenhouse gases really bad? No, these greenhouse gases are not really that bad. Had there been no greenhouse gas, had there been no greenhouse gas present in the atmosphere, had there been no greenhouse gas present in the atmosphere, what would have happened is the average global temperature of earth would have been minus 18 degree Celsius. Average global temperature of earth would have been minus 18 degree Celsius, and this minus 18 degree Celsius temperature would not be habitable and would not be good, or would not be adequate for the survival of humans, right? Or different different life on earth, life on earth. So these greenhouse gases are have made significant contribution in making the earth average temperature as habitable for human life, right? So these greenhouse gases have contributed played its role to make a habitable temperature on earth for human and plant survival, right? So how this has happened is basically, but the problem is this greenhouse gases concentration is increasing. The thing that I have told you earlier here is some of it is being able to escape also, right? Some of these heat radiation are able to escape also. But imagine this greenhouse gases concentration is increasing and increasing. This greenhouse gases concentration is increasing and increasing in the atmosphere. Now these heat will also be not able to escape in the atmosphere. See, this was the small window through which, the example we have seen about car or the greenhouse, right? So this was the small window through which the heat was able to escape in the atmosphere. But now, since the concentration of greenhouse gases is increasing, and because of this we are losing this small window, and the global average temperature is increasing, right? Now the thing is, why it is a concern, or how it is a concern. See, when greenhouse gases are increasing, the concentration of greenhouse gases are increasing, what is happening is the concentration of greenhouse gases are increasing, and it is leading to global warming. Now this global warming, because of this global warming, in the previous classes we have seen this thawing of permafrost happening, melting of permafrost, and we have seen permafrost is sub-zero temperature for continuous 2 years at least. So this thawing of permafrost, now this thawing of permafrost is releasing CO2 and CH4, methane and carbon dioxide, which are greenhouse gases. So this greenhouse gases concentration is again increasing, and it will lead to more global warming. So this is a kind of positive feedback. Right? So this positive feedback is doing what? This positive feedback is increasing global average temperature, and this is the cause of worry for us. This is the cause of worry for us, right? So this is the thing that we need to discuss. Now, when we come to this global warming, these greenhouse gases have played a significant role in making this earth temperature as habitable, because had there been no greenhouse gas, the earth average temperature would not be habitable, Now, coming to the next discussion, that is, see, the average, if we talk about the variation on temperature of variation of temperature on earth, so the minimum temperature that has been recorded is somewhere around minus 85 degrees Celsius, and it has been recorded as a location known as Vostok, which is in Antarctica, right? Vostok, which is in Antarctica, and the maximum temperature recorded on Earth is California, USA, somewhere around 56.7 degree Celsius, 56.7 degrees Celsius temperature, maximum temperature. But one more place is known as warmer, to be famous for warmer temperature, that is Al Azizia place in Libya, but this is not recorded properly. It is somewhere around 57.7 degrees Celsius. So you can see the maximum and minimum temperature on Earth. But if we talk about moon, the maximum and minimum temperature would be somewhere around minus 185 degrees Celsius to somewhere around minus 153 degrees Celsius to 134 degrees Celsius, minus 153 degrees Celsius to 134 degrees Celsius. So this is the comparison with respect to moon, the comparison of the temperature variation on Earth. But these greenhouse gases also played its role in maintaining and minimizing greenhouse gases also has played its role in minimizing this diurnal temperature on Earth. Diurnal temperature on Earth. Diurnal temperature meaning the temperature difference between 24 hours. Temperature difference between 24 hours. The maximum temperature and minimum temperature in 24 hours only. So greenhouse gases played its role in it. But since greenhouse gases concentration is increasing day by day, this is becoming a cause of concern. Now come to a very important discussion, that is this impact of greenhouse gases. Impact of greenhouse gases in global warming. It is measured basically with respect to three parameters. Number one, first we will talk about the abundance of these greenhouse gases in the atmosphere. Number one, abundance. Number two, atmospheric lifetime. For how much duration, once they got released in atmosphere, what will be the duration till when these will be present in the atmosphere? So atmospheric lifetime. And third is global warming potential. warming potential, GWP. So these are the three parameters on which we see the impact of these greenhouse gases on in global warming, or the role, right? So number one, if we talk about abundance, if we talk about abundance, see, water vapor is also considered as a greenhouse gas. Water vapor is also considered as a greenhouse gas, and the presence of water vapor in the atmosphere is somewhere around 0.4%. But since these water vapor are not being given much importance by some experts, some experts talk about the role of water vapor in global warming, but the reason some experts are ignoring it because of its atmospheric lifetime, because these water vapor, these are present in the atmosphere for some days to weeks. That's it, some days to weeks. So these water vapor are not much talked about in the role of greenhouse gases or global warming, increase in global warming, because of its atmospheric lifetime. So these three parameters are important. One, how much amount of how these gases are present in how much quantity in the atmosphere. So its abundance, its presence. Number two is atmospheric lifetime. So if it is released in the atmosphere, for what duration they are remain in the atmosphere, or they are present in the atmosphere. And the third thing is, if they are present for longer time also, what is its global warming potential? What is its global warming potential? So these three parameters are important. So water vapor, 0.4% is its presence, but this is not given much important because of its atmospheric lifetime, right? But when we talk about gases, number one, the most abundant gases and nitrogen, right? Most abundant gases, nitrogen, somewhere around 78%, somewhere around 78%. Nitrogen, 78%. Then it is oxygen. Oxygen is around 21%. Oxygen is around 21%. And we have argon. Argon is less than 1%, 0.95%, right? But to your surprise, these are not greenhouse gases. These three are not greenhouse gases. These three are not greenhouse gases. These three are not. The abundant 1, 2 and 3, the atmosphere, the gases which are present in the large amount or in the atmosphere, these gases are not greenhouse gases. Nitrogen is not a greenhouse gas, oxygen is not a greenhouse gas, and argon is not a greenhouse gas. So the fourth one, that is carbon dioxide. Fourth one, that is carbon dioxide. Carbon dioxide present is so less that it is measured in parts per million. 406 parts per million. 406 parts per million. This is the presence of carbon dioxide, and carbon dioxide is a greenhouse gas, right? Carbon dioxide is a greenhouse gas. Now when we talk about methane, CH4, when we talk about methane, the concentration is so less that it is measured in parts per billion. 1850 parts per billion. 1850 parts per billion. So this is the presence of methane in the atmosphere. When we talk about N2O, it is again in parts per billion. It is again in 330 parts per billion. 330 parts per billion. And when we talk about fluorinated gases, that is chlorofluorocarbon and HCFCs, hydrofluorocarbons, etc. These fluorinated gases, F gases, fluorinated gases, these are in parts per trillion. These are in parts per trillion, PPT, parts per trillion. But see, you cannot say that these fluorinated gases or methane, these are methane or carbon dioxide, since they are in so less amount or so less concentration in the atmosphere, these are not playing big role in greenhouse global warming. These are not playing big role in global warming. Why? Because it's the concentration of these gases are so less in comparison with respect to these gases, nitrogen, oxygen, and argon. The concentration of carbon dioxide, methane, and nitrogen dioxide, these are very less, right? Now, why we cannot say this? The concentration of fluorinated gases are not less? Because of the atmospheric lifetime. Because of the atmospheric, not because of atmospheric lifetime. Yes, also because of atmospheric lifetime and its global warming potential. What is the global warming potential of these gases, right? What is the atmospheric lifetime of these particular gases? See, the concentration is less, but what if the concentration is increasing day by day, and these concentration are not increasing to a significant amount, but once they are released in the atmosphere, what is happening? They are present for longer duration, some for 100 years, some for 1,000 years, some for million of years. So these concentration are remain in the atmosphere for so many years. So the contribution is with respect to lifetime also, the contribution is with respect to global warming potential also. I hope we are clear on this, right? So this is about the abundance of greenhouse gases, right? Now when we come to the atmospheric lifetime. Atmospheric lifetime. Atmospheric lifetime of these gases. If we talk about atmospheric lifetime, see, water vapor, as we have seen, water vapor will last for days to weeks. So this is not a major problem, days to weeks, right? But second, if we talk about methane, CH4, methane, it is for 12 to 14 years. 12 to 14 years. So whatever methane is being released into the atmosphere today, it will remain present in the atmosphere for 12 to 14 years. So this is the atmospheric life that we were talking about, right? For example, if we talk about N2O remain in the atmosphere for approximately 20 years. 20 years. If we talk about carbon dioxide, CO2, why CO2 is considered sometime as the biggest greenhouse gas? Because of its atmospheric lifetime, and its atmospheric lifetime varies from 100 to 300 years. 100 to 300 years. So this is the carbon dioxide, the atmospheric lifetime. Its presence is in parts per million, right? 406 parts per million. But once it is being released into the atmosphere, it remains in the atmosphere for longer duration. It remains in the atmosphere for 100 to 300 years. When we talk about different fluorinated gases, so chlorofluorocarbon, CFC12, these are some numbers of chlorofluorocarbons. So CFC12, when we talk about CFC12 remains in the atmosphere for 100 years. When we talk about HCFC, hydrochlorofluorocarbon 22, it remains in the atmosphere for 12 years. When we talk about some fluorinated gases, example, when we talk about C2F6, hexafluoroethane. When we talk about hexafluoroethane, its atmospheric lifetime is 10,000 years. 10,000 years. So what we can conclude here is, when these gases are being released into the atmosphere, some of it remain present in the atmosphere for 100 of years, and some to the extent of 10,000 years also. So we should be cautious even though the concentration is less, but when the concentration will increase, or once it is released in the atmosphere, its lifetime is so much that we need to be cautious about these particular gases, right? So this is one dimension of it. Now we can move ahead to understand the global warming potential. The global warming potential. The global warming